Hello everyone. So today I'm going to talk about the data classes, the latest module of the standard library for Python 3.7. First, a quick presentation where I am. So I'm Pierre Alexandre SCHEMBRI. I am the founder of NETSACH. It's a software startup that it's based in Paris. We help companies building digital platforms, and we are offering an integration platform as a service to connect all kinds of digital services and perform automated tasks between them. So this talk is divided into two parts. First, we'll make a quick tour around the data class module and see about it, and then we'll talk about some best practices and some unexpected use of this module. A quick note, the data class module is only available for Python 3.7. It has been backported to Python 3.6, so you can use the features, but let's not live in the past. So in the PEP 557, data classes are defined as a mutable name tuple with defaults. So what is a tuple? Basically, it's one of the built-in data structure in Python. And one of the things is it's immutable. You cannot change once it has been created. And a name tuple, it's from the collection module. It's like a tuple, and it is a tuple, but it's named. So you can tie some information about what is the field name. So if we want to create a user using name tuple, we say, okay, it's a user, it has a first name and a last name. And we create Alice, that is the user, and we can print out Alice, like that. As it is a tuple, or a name tuple, it's immutable. We cannot change that. A data class is a normal Python class. And it's important to state that. It is a standard class, and you know everything you know about Python classes is valid for data classes. But what's interesting is that these classes will behave like name tuples, but they are mutable. So you can alter the data inside. And there's also a lot of boilerplate code that you won't have to write because it will be generated for you. So before data classes, if we want to create a user class, we say, okay, there is an init function. We have a first name, last name, favorites. And we will create some initialization code like that. So let's imagine you have a dozen of this class in your application, and each class has at least 10 fields. It will be very boring to write this code, especially if you have to set default everywhere. And it will do nothing. It's just initialization code. So let's see how data classes will help us to write the same thing. So we have an import. From data class, we import the data class decorator. And we will decorate a new class, a user. And we use type annotation to give information about the field that we will create. So we say our user, it has a first name, it has a last name, it has favorites. And we say it's a string, and for our favorites, it's a list. Here, we still have normal Python code. So there is no type checking. You can set anything you want. This is just information. And that's the beauty of it. But if we want to add more information, you can use the typing module. And there's a talk just after mine that will describe, I think, more in depth. So for better information, using the typing module, we say, OK, the first name, it's a text. It's a string, but it's any kind of text. The same for the last name. And for the favorites, we said earlier that it's a list. But we will add information about it's a list of text. So we don't want anything besides that. However, we did not initialize our instances when we will create users. And right now, all the fields are mandatory. So when you create a user, you have to set all the fields. So now let's talk about defaults and how to set default values. When you create a Python class and you write the initialization code, a default value is often set like this. So this innocent-looking code will become your worst nightmare. And don't do this. The fact that I want to talk about that, it's because the init code, the line, the statement, def init self dot favorites equal square brackets, will be executed at import time and not at runtime. So once the module has been imported, the favorites keyword will be set and will be tied to a list, but the same object for all the class and all the instances. So when we do self favorites equal favorites, we will point at the same memory zone, the same object. So for our user, it will be all the instance of user will share the same object. And this will give us something like this. Imagine in the initialization code, we want to append some defaults. So, OK, let's say test. And then we create a user, we create another user. And for the first user, we say, OK, what's the favorites? And we look at it, and there's 3x test. That's because we initialized the favorites with a mutable argument. So favorites equals square brackets, that's bad. Don't do that ever. We need to avoid side effects when writing classes, and using mutable defaults will generate some side effects that will wake up at night because the application will crash. And I don't like to be waken at night. So what we need is to avoid doing this kind of mistake. Using data class defaults, we'll create some fields to add the default. And how to do that? You import the field function from the data class module, and you say, OK, for first name, I will use the default and say, OK, my first name is Jane, Jane Doe. It's a default value. And when I try to do the same thing as before, and I say, OK, favorites, it's a list of text, and the default is square brackets, no, it's impossible. The data class module won't let you do this mistake, because we know that it is a mistake. But when you're a rookie programmer, you don't know that. So it even comes with an advice. Use default factory. OK, what is default factory? For a mutable field, like a list, you will have to use a default factory. It's like the default dict in the collection module. And it's basically said, OK, each time I don't want to set the value, and I will rely on the defaults, I will give a constructor, a factory, in the factory pattern, to build the favorites using a callable. So we just type list, and it will create, each time we create a user, it will create a new list for each user that is not shared between users. So the data class module prevents you from making this kind of costly mistakes. So let's just say what you just got for free using data classes. We define a class, we set some defaults, and when we create an instance, we can see that there is some functions that are built in. So we have a rep function that is created for us on top of the init function that we never saw. And it's exactly the same as the name tuple. Each of the fields are nicely print out. So you can print your user and say, okay, that's the kind of information that I have in my class or in my instance. And there's also some function that will help you work with instance of data classes. For example, the asDict or the asTuple function that will convert your instance into a dict. But nothing special. You can even add a special factory for your asDict to use a special type of dict. There's also a small set of other features that we will see in the next slides. One of the key features that Dataclasses also pushes to you, it's the immutable instances. So we saw that name tuple were immutable. Dataclass brings us mutable with defaults, but we can still have the immutable kind of behavior just by adding the frozen keyword equal to true. So by doing that, you're basically saying, once my user is created, it cannot be changed. So when I create John, I cannot rename it to Roger. And it's an exception, a frozen instance error exception is raised, so you cannot go further. Why doing immutable instances? We saw that just before. Because maybe later in your code, you will have to initialize your code with some default values, and you want your default values to be immutable. So you need immutable values at some point. But there is another bonus to having immutable instances. It's that you can hash them. So as soon as you can hash your instances, you can use it in sets. And using sets to do data manipulation is just the best tool ever, because you can work with ensembles and perform all kinds of union and intersection. So for example, we have a user, we have a project. We specify that it's frozen, so they are immutable. And once they are created, you can do a set of the current project, and you can use the instance as keys of dictionaries. So when you're creating some kind of complex data structure to help you process large amount of data, it will be very nice to use your object as keys to dictionaries. So now let's see more about fields. So when you create fields, you remember that you can add some type annotation to indicate information about what's the expected type. There is no type checking. It's just information. And you can set a default value, as we saw before. You can set a factory for mutable defaults using the default factory, just like the default dict of the collection module. And you can also tune the generation of the rep, hash, and compare function that are built in your class. For example, if you have a model, a data class that embeds large amount of data, like base 64 encoded data or binary data, you don't want to be in the rep because it's not easy to read. So you can exclude one of the fields or some fields of the rep function. You can also exclude some fields of the hash function because hashing large amount of data will take some time and your performance will go down the drain. And one of the last parameters called metadata, which is my favorite, it's a parameter that allows you to add customization. It's a customization hook. And let's see how we can use this. So when you create a class and you want to access the information about the fields, you will use the fields function of the data class module. and it lets you introspect the attribute of the class. So when you say, okay, f equal fields user and the first one, square 0, you will obtain the field that is first name. So you have the name of the field, but you also have the access to the metadata attribute, where you can put anything you want. So here you can say it's a dictionary. You can set any key value dictionary. So it's basically encourages you to use this this attribute to perform maybe some other magic or something less more common. Sorry. For example, for the first name, you can add a verbose name. You say, okay, I want to display my user and the field, it's first name, but I don't want an underscore. I don't want to perform some complex manipulation. And I'm sure a lot of you have seen this pattern in frameworks like Django. So you can add information like this. I think in the near future, the Django developer team will migrate to data classes. And we can also imagine some kind of more complex use case and say, okay, we have an image. And this image will be stored as a byte string inside our object. And we say, okay, but at some point, we may be able to want to load data from specific loaders or some dynamic information. So we can specify, okay, for this field, I support some loaders, and I give a list of all the loaders that I can support. So we can imagine any kind of complex logic built in the class definition. But just to bring some information, because there is no code. It's just info. I'll let you imagine what could be done. So, taking a step back, data classes are a way to describe data structures. Okay, that's the basics. But on top of that, it helps you write self-documented code, because you can add information that will not be a docstring. It's embedded in the class definition. And it helps you create some safe defaults that will not break your code later during the night. It helps you achieve one of the hardest things to do in Python, that is to create data that can be set as frozen, immutable. It's hard to achieve, and it's boring to do that. So you have that for free. And on top of that, you have the customization hooks that I like the most. So in short, I would say that with the collections module, the data class module is one of the rare modules of the standard library that pushes you the best practices to use and how to protect from doing mistakes. If you want more information about data classes, I will recommend you to look at the talk by Raymond Ettinger that he gave on the latest PyCon earlier this year. And it's interesting because he describes data classes as a code generator to end all code generator. For the links, you'll have I'll upload the slides later. So, in this part, I want to show you how to use this kind of functionalities that are built in this module, and how to define interface for your application. And by interface, I mean internal interfaces, like an API for co-workers, for developers. And let's see with an example. when we work on large projects involving large teams, we often find the common source of bugs as to be the interface between modules. Because one team say, okay, I will push you that kind of data, but it's not the same type, or there's unwanted behavior. So you want your interface to be as clear as possible. Even with dedicated documentation, it will be hard to maintain. It will ask you a lot of work. And even with outdated docs, the source of truth is always the code. When there is a bug, there is something that's not working, you say, OK, let's go look at the code. You're not saying, look at the documentation. When there's a bug to fix, you go look to the source code. So we need to have an understandable and a clear code. That's a task, just that. And because we're writing Python to share, we're writing Python for other people, for humans. And that's the beauty of this language. It's nice to read because it's well formatted. And even a single developer, when he writes some functionality, and he has to go back in time because he has to go back to fix, if the code is not clear, it will be horrible. So we need to push the fact that we need to write understandable code. Okay. When we study computer science, we need abstraction. And why do we need abstraction? To build better software that will be able to address a larger set of problems. But writing understandable code and abstraction is complicated. And better, you want your code to be consistent, to have consistent interfaces. And when you add abstraction, understandable code, and consistency, it's a huge amount of tasks, of work. So Trey Hunter, in a talk that he told about how important it is to have readable code. So you can look at it; it's very interesting. And Brandon Rhodes talked about how consistent interfaces are important to allow to discover some hidden features, and how Python has taken so much from the Unix world and so much from the Unix traditions over the past. So now let's see, with an example, how we could achieve that. It may be not perfect, but it's an attempt. When we write automation workflows, we often use state machines because it helps us describe large and complex tasks into smaller parts. How would we define an interface for a state machine platform? The best way is to first write interfaces in order to be able to write tests, and in order to be able to enforce the fact that we are using test-driven development. If you're not doing test-driven development, I encourage you to look at how we can achieve that. And finally, we write implementation. Dataclasses will help you write the interfaces. So we have a state machine. Let's create some data structures. We have a state in which the machine will go. We have events that will act as possible transition to go from one state to another. And we have a machine that will run some tasks in some state. If we want to define a state, we say, OK, let's create a data class. Let's use the typing module to add information. We have a name, and we have tasks. And tasks, it will be functions. So if we want to be functions, we say, okay, it will be callable. But it's a set of callables. And why a set? Because in a state, you want to perform a specific set of tasks and not add tasks on top of something you didn't forecast. And so we use a frozen set to be able to say, okay, the state will be a frozen data class. So each state will not be able to be mutated. Then we define an event. An event that is received by the machine will basically help us to go from one state to another. And like the state, we don't want to alter our events. We create our events, and once they are created, we don't want to change them. So we use the name, we use a source and a destination. And as we defined earlier the state class, we can use in the type annotation to say, okay, source, it's a state, and destination, it's a state. Next, the machine. So let's take our time and look step by step what we did. So our machine, it's a data class, but it's no longer frozen. It's mutable because it will be alive. We have a name, okay. We have a current state. The current state will be like a pointer to say, okay, my machine is in that particular state. I said that we want to run some tasks. How to run some task? How can we do that? We will provide our machine with a run task attribute, and we say, okay, we want that to be callable. It will be a function that somebody will call, and that will be able to run the task in the particular state. And because we want our machine to hold some data, I say, okay, let's add a context. A context that I define as with a field with default factory with a dict. So, okay, context, it's a dictionary. But I did not use the dict type annotation. I say, no, it's a machine context. And why did I do that? Because when I will call run tasks, I don't want any type of information. I want the machine context. So I define the type machine context as a dict, and I say, okay, run task will take machine context, and context is my context. It's my information. And keep in mind, there is no functionality. It's just information. It's information for developers to help them write tests, then write an implementation. Yes. Finally, the events. So basically the events, we want to push events onto the machine to make some kind of movement to be able to go through states. And we'll use the deck type. So the deck type is a queue. It's a double-ended queue. And it's like a normal queue, but you can push and pop data from both ends of the queue. And as it's an event, it's a double-ended queue, we say, okay, it's a double-ended queue of what? Of events. We use the default factory deck from the collection module to initialize with an empty queue. And we use the metadata keyword to say, okay, we'll add some information about what I want as a designer. I want new events to be append left on the queue. And I want unprocessed events to be popped on the right. So the machine, as I see, will pop events, unprocessed events, to say, okay, there's events that will be processed in queue, and the first that comes in comes out on the other side. The actual implementation of all the functions, the run task, anything like this can be very rich and very domain dependent. Imagine we have to retrieve tasks from an API or from a file or anything. I don't want to say anything about that. But what's very interesting is that we have a working code. We can play with this code. We can create a machine. We can create states in a unit test. So we can start trying to imagine some of the key edge case or write our expectations in the unit tests. So let's take a step back and I say, okay, data classes plus the typing module, it's the best way to write specification. And not any kind of specification because it's not a document, it's code. It's specification as code because you have a working class, you have working instances, and you can play around. I believe we can even replace some abstract-based classes by data class in some case where we use them as interface specifications. And on top of that, we saw earlier that the data class module helps us and pushes you the best practices ever. So I would really recommend anyone to dig into this module and start using Python 3.7 in their project right now. Thank you. That's it for today. If you have any questions. So we have 5 minutes.
Thank you for your talk. Do you know Atlas, the project?
Yes.
How do you compare it to?
Yes. I mentioned in the end. So it's basically the source of inspiration to build data class. So it's Atlas is for Python before 3.7.
Do you think that data class is going to make Atlas obsolete?
It's like async.io and twisted. Once it is in the standard library, it will maybe reach a larger adoption.
Because data classes don't offer everything that Atlas does now.
I don't know because I did not dig into Atlas in deep. Yeah.
Very small question. First of all, thank you for the very good talk. My question is, when you declare a field,
yeah.
Is the type annotation mandatory?
So the question is, when we create a field, is the type annotation mandatory? I don't think so. No. But it's it would be a shame not to use it. Yeah.
You showed that there can be frozen instances, but can you have only part of the instances frozen, like on some?
Okay, so the question is, can we have some of the fields that are frozen and not all the instance? No, we can't. Not with the frozen keyword.
Okay. So you would have to implement it by other means.
Yeah, or play with some kind of other kind of standard way to do that with properties, for example.
If you wish to customize the init method, can we still reap the benefits of data classes?
Yes. Yes. So the question is, can you use the benefits of the generated init method and still add some customization? Yes, you can using the post init hook. There is a post init hook that you can implement that will be called just right after the init method. Okay, I think that's it. Thank you.
Thank you.